Welcome to The Explainer. Today, we're going to break down the incredible and honestly pretty accidental history of the drugs that totally changed how we treat depression. Yeah, I know, it sounds like something out of a sci-fi movie, right? But it's absolutely true. So today, we're diving deep into the strange and fascinating story of antidepressants. It's really a tale of desperation, a whole lot of lucky accidents, and the incredible evolution of how we understand the human brain. Okay, so before we can even get into the treatments, we really have to understand the illness itself. And let me tell you, it's so much more complex than just feeling sad or having some kind of simple chemical deficiency. Yeah, we're talking about a serious clinical condition here. An untreated episode of major depression can drag on for, on average, 11 months. And what's even scarier is that each episode you have actually makes the next one more likely to happen. And the symptoms? They are absolutely devastating. This goes way beyond just a low mood. It can creep into every single corner of a person's life, affecting everything from their physical health to their basic ability to just get through the day. So, for decades, right, the story we all heard was that depression was just a chemical imbalance, a simple lack of serotonin. But what the science is showing us now is that the reality is way more complex. We're talking about actual physical changes happening inside the brain. Okay, so think of it this way. In major depression, the body's stress response system gets jammed in the on position. It's like the alarm is always blaring. The brain gets flooded with a stress hormone called cortisol, and over long periods, that stuff can actually be toxic to brain cells. And that leads to this. It's kind of like a city going through a major power brownout. The brain's neurons, their cells, see a 30 to 40% drop in their metabolic rate. They just don't have enough juice to run properly. And that causes a huge slowdown in overall brain activity. And all of this leads to a really crucial point. Depression is not just a state of mind. It can cause real, tangible physical damage over time. Those connections between neurons start to get lost, and the brain's cortex can literally get thinner. And that is why getting effective treatment is so incredibly important. So if that's what's happening in the brain, what did we do about it? I mean, before we had modern medicines, the options for treatment were, well, they were primitive, often brutal, and honestly, they were born out of pure desperation. Just take a look at this timeline. It really shows you the state of things. We're talking about everything from asylums and so-called rest cures to chemically inducing seizures. These early approaches were based on a very, very limited and often totally flawed understanding of the brain. Now, this slide really illustrates the incredible progress we've made, especially with something like ECT. The early version, back in the 40s, no anesthesia, incredibly dangerous. It earned a truly horrible reputation. But modern ECT is a completely different world. It's safe, it's humane, and believe it or not, it's still our single most effective treatment for the most severe, treatment-resistant cases of depression. All right, now we get to the really wild part. Because the first real antidepressants, they weren't carefully designed in a lab to treat depression. No siree. They were discovered completely, and I mean completely, by accident. I mean, check out this chain of events. It's incredible. So World War II ends, and there's this massive surplus of hydrazine missile fuel just lying around. Scientists start messing with it, trying to use it as a base for new medicines. They end up creating a drug to treat tuberculosis. But then, doctors notice this bizarre side effect. Their TB patients are becoming euphoric, even manic. They were just so happy. And just like that, totally by accident, the first class of antidepressants, the MAOIs, was born. And you won't believe it, but lightning basically struck twice. Around the same time, a totally different group of researchers were testing a drug they hoped would treat psychosis. Well, it was a total failure for psychosis, but it turned out to be amazing at improving mood and anxiety. And boom, this happy accident gave us the second major class of early drugs, the tricyclic antidepressants, or TCAs. So, don't get me wrong, these first-generation drugs, the MAOIs and TCAs, were absolutely revolutionary. But they were also really dangerous. So the next great leap forward wasn't actually about making a stronger drug. It was about making a much, much safer one. And when I say dangerous, I mean it. The risks were severe. With TCAs, an overdose of just a week's supply could be lethal. With MAOIs, you could have a deadly spike in blood pressure just by eating certain foods, like aged cheese, or even taking a common cold medicine. Now think about that. For a population that's already vulnerable to suicidal thoughts, this was a massive problem. And that's why the introduction of SSRIs, starting with fluoxetine back in 1987, was such a game changer. The number one reason? The risk of a lethal overdose just plummeted. It was a huge shift. Safety all of a sudden was the top priority. And this, right here, is where that whole serotonin story we talked about earlier really took off. See, SSRIs work by selectively targeting one specific neurotransmitter, serotonin. They basically block it from being reabsorbed too quickly, which means there's more of it available to do its job. This much more targeted approach is what made them so much safer. And it also turned out to be incredibly effective for a whole bunch of other conditions too, like PTSD and OCD. Okay, so let's fast forward to today. Where are we now? Well, SSRIs make up something like 70% of all antidepressant prescriptions out there. They're everywhere. But our understanding of how they work and the challenges we still face are constantly evolving. Which brings up the big question, right? With millions and millions of people taking these drugs, how well do they actually work? And the answer, well, it's a little more complicated than you might think. When you look at the data, it's actually pretty sobering. For any given antidepressant, only about a third of people who take it achieve full remission, meaning they get all the way better. Another third see some improvement, but they don't fully recover. And then there's the last third, who just don't respond at all. So it's roughly a three-way split. And this is what brings us to our modern understanding, which, again, has moved way past that simple low serotonin idea. The new thinking, as this quote points out, is that depression is really about the brain's inability to regulate itself. Antidepressants aren't just filling up a chemical tank. What they're really doing is helping the brain restore its own ability to control things like mood, emotion, and memory. And that really highlights the big takeaway here. There's no single magic bullet. For most people, the most effective path to getting better isn't just about a pill. It's usually a combination of things, using medication to help stabilize the brain's biology, while also using tools like psychotherapy, exercise, and other lifestyle changes to build up resilience and learn new coping skills. So that leaves us with this final question. With a full third of patients not really responding to our best medications, what's next? The quest for better treatments is far from over, with scientists looking at everything from modulating cortisol to using direct brain stimulation. And it just makes you wonder, after a history filled with so many lucky breaks, what will the next accidental discovery be?